Dear students, I am Bhumiraj Adhikari. I am mathematics teacher in Oxford schools, Pokhara, Thodi, Bazapatan. Today I am going to present demo lessons for grade 10 students that belongs to chapter 1 sets. Set is a collection of well-defined objects. You know very well. Let me start the lessons of today's lessons. Cardinality of a set. The number of elements of a set is called cardinal number of a set. It is denoted by n of A. For example, a set contains the elements 2, 4, 6, 8, 10 and 12. There are 1, 2, 3, 4, 5, 6. 6 elements. That is why the cardinal number of the set A is 6. Some of the questions. Now I am going to talk about union and intersection of sets, which you have already learned in previous class as well. Even though I am going to give you some basic knowledge here too. A set A has elements A, B, C, D and E, and another set B has elements M and O, P. See here, there are no any common elements. It means if there are no any common elements between two sets, that types of sets are called disjoint sets. This set contains 5 elements. The cardinal number of set A is 5. The cardinal number of set B is 4. Now, if they have no any common elements, the intersection of A and B, intersection of set A and B is 0, because there is no any common elements. Now, the union of a set, the n of A union B is equals to n of A plus n of B. N of A is equals to 5, n of B is equals to 4. That equals to n of A union B equals to 9. Now, okay, this is the example of disjoint sets. Let me students, this is the example of union and intersection of sets. The two sets are overlapping now. Young contain elements 21, 24, 27, 30, 33. That equals to n of young equals to 5. Here too 30, 33, 36, 39, 42. The n of young equals to 5 elements. Okay, this Venn diagram represent this 30, 33 is a intersection of two sets, and this young and young contain n of young union n. From here we can say that the cardinal number of young intersection young equals to 2. That you can identify from here. The intersection portion is this. This is the common portion of set young and set young. 30 and 33 contained in both sets. That is why there are 2 elements. That equals to 2. And that gives the concept about young union young. Young union young is an exam M means the all elements contained in set M and N, but we do not repeat the elements twice. And now M union N means and now the elements contained in M are 5. 1, 2, 3, 4, 5. Elements contained in N are 1, 2, 3, 4, 5. That is why 5. And we count 30 and 33 twice in set M, also set in N. That's why we count 30 and 33 twice. That's why we reduce 2, because we do not count the elements twice. 5 plus 5 minus 2 equals to 8. Then you can be more clear from the Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8. That is M union N. Students, now I'm going to talk about the problems including 2 sets. Okay, list of some formulae. Okay, now N of A union B is equals to N of A plus N of B. When set A and set B are disjoint, there are no any common elements. We just add 2 sets to find the N of A union B. If sets are disjoint, if set A and set B are overlapping, N of A union B is equals to N of A plus N of B minus N of A intersection B, as I taught already. You can see from this Venn diagram as well. This is set A, this is set B, and this portion is a common portion of set A and set B. That is called N of A intersection B. And this portion is only belongs to set A. This portion is not belongs to set B, only for A. That is why this portion is donated by N of only A. Similarly, this portion is not belongs to set A. This portion is only belongs to set B. That is why we donate for this portion as N of only B. And this is whole. All portions is N of A union B. And the portions out of A union B, this portions is, this all portion is A union B, and the portions out of A union B is donated as N of A union B complement. We can say this as, in another way, the portion out of A union B. The portion out of A union B. Now, N of A union B complement means N of U minus N of A union B. You can clearly see from Venn diagram. If you subtract these rectangular portions contain all elements of the universal sets. If you subtract A union B, these portions from these whole universal sets, what left? The the persons outside is left, that is A union B completed. We can see in formula as well, n of U minus n of A union B. Also, how do we find only A? Okay, you can see from here, this is set A. If you subtract this portion, if you subtract these portions from set A, what left? Obviously, this portion left. Yes, this portion left. These portions mean only A. Only A means n of A minus n of A intersection B. Likewise, if you subtract common portion of A intersection B, this portion from say B, what left? Only B. This portion left. What does this mean? Only B means what? B minus A intersection B. Okay. We have another formula for A union B. Now you can say from this Venn diagram as well, A union B means all elements of this process. Now, okay, if you this process is only A, this process is only B, and this process is A intersection B. Only A plus only B plus A intersection B means what? N of A union B. Okay, you can see from here as well, N of A union B is equals to only A plus only B plus N of A intersection B. Okay. Also, okay, what does universal set mean here? The union of A and B plus A union B complement means this whole universal set. That is why N of U is equals to A union B plus N of A union B complement. Okay, and now I have one logical questions for you. Okay, please get ready to answer this question. I request you to pause this video and think and answer the question, please. Okay. If set A contains 6 elements and set B contains 5 elements, what is the maximum value of cardinal number of A union B and minimum value of A union B? Also, maximum A intersection B, minimum N of A intersection B. I request you to pause this video and think and please answer the question. But okay, now students, then what is the maximum A intersection B? In what condition it will be maximum, and at what condition it will be minimum, at least, at most, and at least. For this as well, possible maximum A intersection B and possible minimum A intersection B. Let me start from here. A intersection B means the common elements of A and B. The minimum means very less. If set A contains 6 elements, set B contains 5 elements. If set A and set B has no any common elements, if set A and set B are It means N of A intersection B will be 0. This is the minimum value of A intersection B. Now think about this. Maximum A intersection B. Set A contains 6 elements, set B contains 5 elements. Okay, can it be possible to be 6 common elements? I think not, because it has only 5 elements. So, maximum common can be only 5. So, maximum common elements of set A and B is equals to 5. There is no more than 5 common elements in these two sets. For here, let me start from here. A contains 6 and B contains 5 elements. If there are no any common elements, if these two are disjoint sets, N of A plus N of B is equals to A unit B. That is, the maximum A unit B is equals to 11. And for this, minimum, in what condition that would be minimum? If all elements of set B contained in set A, all 5 elements are common, then 6 plus 5 minus 5, that equals to 6. The minimum A union B of these two sets is 6. How it is possible? If all elements of set B are common at set A, in that condition, that would be made. Students, we have a problem based on two sets. Okay, the question is like this. In a survey of 60 students, 30 drink milk, 25 drink curd, and 10 drink milk as well as curd. Draw a Venn diagram to illustrate this information. Find the number of students who drink neither of them. The question is like this. Let me write the information provided in the questions at first. Okay. In a survey of 60 students made, the total number of students participate in the survey is 60. That is universal set. N of U is equals to 60. The U represent total number of students included in the survey, and M for the number of students who drink milk. That is N of M is 30. 30 like to drink milk, and C stands for curd. Who like to drink curd? Then there are 25 students. Number of students who like to drink curd is 25, and 10 drink milk as well as curd. The number of students, the number 10, they like to drink both milk and curd. They are common of milk and curd both. That is written as like this. Young intersection C is equals to 10. According to the questions, we are going to illustrate this information by using Venn diagram. Let me draw Venn diagram here. Okay, solution. Okay, this solution is already there. Okay, this diagram for the number of students who like milk, this is for milk, and chord both, and this is young union C, and this is out of milk union chord. They do not like to drink milk and chord. Those students we include here, they do not like to drink milk and chord both. Now, using these information, the students who like both, is 10. So we write here 10. And how many students like to drink milk? 10. Oh, sorry. 30 students like to drink milk. Okay, the total number of students in this circle is 30. 10 are already there. So how many left for only milk? Please. 30 minus 10 equals to 20. They like to drink only milk. Okay, let me go for the chord. How many like to drink chord? 25. And 10 students are already there. How many are left for only chord? 25 minus 10 is equals to 15. They are left for only chord. Now, okay, the diagram is not completed yet. Still, we have some things to do. Okay, there may be some students, they do not like to drink both drinks, neither milk nor chord. If they like to drink milk, they include here. If they like to drink chord, they include here. Then, if they do not like to drink both, where do they lie? Obviously, they lie out of these two here. That portion is milk union C complement. That is unknown for us. Find the number of students who drink neither of them. We need to find out this. So let us suppose how many students are here? Yes. We can let X number of students do not like to drink both of them, both of the drinks. Now using this Venn diagram, we can solve very easily. Using Venn diagram, N of U, total number of students. N of U is equals to this only milk plus only coffee plus milk intersection coffee plus this and milk union C complement. And just put the value of them in, and of U is equals to 60 or equals to only 20 plus 15 plus 10 plus X. Now solve it. 60 is equals to 35, 45. 45 plus X. Therefore, X is equals to 50. Now, what does X mean? X is the number of students who drink neither of them. Have you understood? Okay, thank you. Students, we have a problem based on two sets. Okay, the question is like this. In a survey of 60 students, 30 drink milk, 25 drink curd, and 10 drink milk as well as curd. Draw a Venn diagram to illustrate this information. Find the number of students who drink neither of them. The question is like this. Let me write the information provided in the questions at first. Okay. In a survey of 60 students made, the total number of students participate in the survey is 60. That is universal set. N of u is equals to 60. The U represent total number of students included in the survey, and M for the number of students who drink milk. That is N of M is 30. 30 like to drink milk, and C stands for curd. Who like to drink curd? Then there are 25 students. Number of students who like to drink curd is 25, and 10 drink milk as well as curd. The number of students, the number 10, they like to drink both milk and curd. They are common of milk and curd both. That is written as like this. Young intersection C is equals to 10. According to the questions, we are going to illustrate this information by using Venn diagram. Let me draw Venn diagram here. Okay, solution. Okay, this solution is already there. Okay, this diagram for the number of students who like milk. This is for milk, and this is for curd, who like to drink curd. Then we can see this is the common portion of milk and curd both, and this is young union C, and this is out of milk union curd. They do not like to drink milk and curd. Those students we include here, they do not like to drink milk and curd both. Now, using this information, the students who like both, is 10. So we write here 10. And how many students like to drink milk? 10. Oh, sorry. 30 students like to drink milk. Okay, the total number of students in the circle is 30. 10 are already there. So, how many left for only milk? Please. 30 minus 10 equals to 20. They like to drink only milk. Okay, let me go for the curd. How many like to drink curd? 25. And 10 students are already there. How many are left for only curd? 25 minus 10 is equals to 15. They are left for only curd. Now, okay, the diagram is not completed yet. Still, we have some things to do. Okay, there may be some students, they do not like to drink both drinks. If they like to drink milk, they include here. If they like to drink curd, they include here. Then if they do not like to drink both, where do they lie? Obviously, they lie out of these two here. That portion is milk union C complement. That is unknown for us. Find the number of children who drink neither of them. We need to find out this. So let us suppose how many students are here? Yes. We can lay X number of students do not like to drink both of them, both of the drinks. Now using this Venn diagram, we can solve very easily. Using Venn diagram, N of U, total number of students. N of U is equals to this only milk plus only coffee plus milk intersection coffee plus this and milk union C complement. And just put the value of them. N of U is equals to 60 or equals to only 20 plus 15 plus 10 plus x. Now solve it. 60 is equals to 35, 45. 45 plus x. Therefore, x is equals to 50. Now, what does x mean? X is the number of students who drink neither of them. Have you understood? Okay, thank you. Okay, my dear students. Okay, this is the questions. This question is for you. Okay, please you try the question first. Okay, while trying, please pause this video for a while, like 5 minutes, 8 minutes or 10 minutes. You can pause the video and you try yourself. If you are not able to solve the problem, then you can again restart the video. Then I will do myself. You can see from my idea. Okay, please. I hope you will follow my instruction. You are very honest students. I feel so. Okay. If you have done correctly, okay, congratulations and keep on doing like this. Okay, if you are not, please follow me. In our survey of 119 students, the total number of students participated in a survey are 119. It was found that 16 drink neither Coke nor Pepsi. 16 do not like any drinks. 69 drink Coke, 39 drink Pepsi. Among them, 69 drink Coke, among them 49 drink Pepsi. Now we have some questions. How many students drink Coke only? How many students drink Pepsi only? And one more information, one more questions for us. So this information in Venn diagram. Okay, solution is like this. in a survey that represent for n of u, that is universal set, n of u equals to 119, 16 drink neither Coke nor Pepsi. It means n of C stands for Coke and P stands for Pepsi equals to 16. Okay, n of C union P complement equals to 16 and 69 drink Coke. C for Coke. Okay, C stands for those which drink Coke equals to 69 and n of P stands for Pepsi equals to 39 like to drink Pepsi. Okay, we have this information. We have now, okay, now you can see this. The total number of students who like to drink, the total number of students participated in the survey are 119 and number of students who drink neither Coke nor Pepsi is 16. Now can you please tell me n of C union P is equals to what? N of U minus n of C union P complement. From using this formula, you can find C union P. Okay. 190 minus 60, that equals to 103. That equals to C union P 103. Okay. Using these informations, these and these, you can find. Okay, let me go here. N of C intersection P. The number of, I'm going to find the number of students who like both drink. That equals to n of C plus n of P minus n of C union P. That equals to 69 plus 39 minus 103. That equals to 108 minus 103. That equals to 5. 5 students like to drink both drink. Okay, now we are very close to the answer. Now, how many students drink Coke only? We have to find out only Coke, that is cardinal number of C minus cardinal number of C intersection P. That equals to 69 minus 5 equals to 64. 64 like to drink only Coke. Similarly, how many students drink Pepsi only? The number of students who like Pepsi only is equals to n of P minus n of C intersection P is equals to 39 minus 5 equals to 34. They like to drink only Pepsi. And we have got all informations. Then we are going to illustrate these all informations in Venn diagram. Okay, let me draw somewhere in the side of a whiteboard. Okay, this is for Coke, this is for Pepsi. Then how many? Okay, Pepsi, who like only Coke. This is for only Coke. 64. Who like only Pepsi. 34. And neither Coke nor Pepsi. That portion. Okay. How many? 60. Okay. Please check your answer with the solution. Okay. And this much for today. Then we'll join with next video in the next lessons. Thank you very much.